Hi everyone. In this video, I'm gonna start with, from the where we left off in the previous video. So in this video, we're gonna include with the physical and security as a enabler of confidentiality. So based on the adoption of artificial intelligence algorithms that may lead to new techniques that can detect the need for enhanced security mechanisms to be dynamically activated early, such technologies should not considerably affect the transmission spectral efficiency. These 2 points are very critical for applications that require the spectral efficiency to be is the same as it was carried out during the transmission, and the technologies when detecting any threat or attack should be activated earlier. So, and for human-centric mobile communication, wireless body area networks and on-body and body nano devices, including biochemical communications, the human body will be a part of the network, as we already know, and it will be seen as a node of network or set of nodes, wearable devices, implantable sensors, and nano devices. So we have two different scenarios. One is related to non-human devices and nodes, and another is related to human-centric devices in where the human body is actually a part of the node and is considered as a node, or it has a set of nodes which are wearable devices and implantable sensors and nano devices. Distributed and cooperative physical security protocols for 6G networks. Physical based key generation solutions distinguish themselves from traditional key exchange solutions. How is that? By completely decentralized and not relying on any fixed parameter designed by a particular entity. This is a game changer, and this is the first vital difference between critical traditional key exchange solution, because in the traditional key exchange solutions there is a third party involved. So in terms of say integrity, the traditional key exchange solutions are not uh, uh, as not as 100% accurate and safe than the physical base key generation, because there is no any fixed reliance on a particular entity to provide fixed parameters, but rather on the distributed entropy source, which is usually wireless data. If comprehensive security is not embedded into these services, new attack vectors will arise at the physical layer in the form of, for example, let's say range extension, reduction attacks that can spoof distances between these devices with a secure communication link. The available physical attributes can then also be used for physical threat detection. Yes, distributed and cooperative physical security protocols for 6G networks. The true potential for threat detection lies in machine learning, as I already discussed, because where massively aggregated attributes can be used to train machine learning models for monitoring and classification. Uh, the usage of machine learning methods in networks with high physical attribute visibility will enable real-time physical layer monitoring and knowledge-based detection, making it highly attractive for leading AI companies to develop security as a service application. But I think in order to get to the step where AI companies can develop security as a service application, there's a huge gap to be filled, and it will take time, because uh, in order to implement massively aggregated attributes, what these include are the devices, are the in-body and out-body devices, and are is related to everything starting from the satellite to human-based devices, inside the and outside the device, human-based devices. These contribute the aggregated attributes, because these devices are going to exchange im- immense amount of data, and at the same time these will they will also have their own particular data to that is going to be shared, and by using these data, the ML models can be trained for monitoring and classification. So in order to bridge this gap, and in order to fill this uh, requirement, the AI companies have to uh, take into consideration huge amounts of information, and I will have to deal with the uncertain and unknown criterias and unknown situations. So this is going to be very uh, complex. It's not going to be easy to implement, but this can be seen as an extra and feature for 6G and the coming 6G future wireless networks. Physical layer security using visible light communication. This is another, as you can interpret as a way of using a physical layer in terms of visible light communication, because here visible light is used. From the picture, we can see that we have how actually transmission is done through using light, because if uh, in normal lighting situation in a house, the power is coming from the a power source, which is actually the electricity provider at the government or private sector, and it is using coming from the meter, and the wires are usually are coming from the meter that attached to the lighting source, that is the LED light or infrared light, for example, and the wires are used in order to carry the electric current from the source to the LED light. So the transmission, if we talk about the visible light communication, the transmission is done, and in this scenario the electric current is not being used for only to light the area, it's used for communication, and the source is a network connection, and high throughput technology is actually used, and the LED light is conveying the data through light and to the devices that are, for example, mobile and the laptop. Lighting area is equal to light area is equal to connected area, and for the data stream, and the mobile and the laptop have sensors, specially designed sensors that are detect light and decode the data that is being conveyed through this way. So VLC is particularly considered as an emerging technology. Yes, it is. It is a special form of optical wireless communication and uses white LEDs to encode data in the optical frequencies. And some studies have suggested that it is a good candidate to meet the data rate requirements for 6G. Physical security using visible light communication. In 6G, a first line of defense against eavesdropping attacks. The key idea behind it is to utilize intrinsic properties of the VLC channel to realize enhanced physical layer security. Physical layer security in a normal way includes recording, jamming, mapping, and subset selection. Recording plus jamming and subset selection plus jamming. But if we use the VLC, this is this is in terms of properties. VLC channel is different than a normal channel, physical channel. So the most in the practical communication scheme for relay system is the intensity modulation and direct detection. Due to the nature of light, the intensity modulating data signal must satisfy a positive value amplitude constraint. So guys, this is for the this video, and in this in the in the this previous video and this video we talked about the first part, the second part, then the third part, and in the next coming video we're going to talk about the fourth part, and after that we're going to conclude this presentation. So be sure to watch the video. Thank you.